After you've started Part Analyzer, go ahead and import a 3D solid by double-clicking and selecting a part file. Over on the left, we see these fields that need to be filled out before we can do any simulations. So I'm going to go ahead and select titanium for this part. And for the units, I'm going to select millimeters. These are the units that it was saved in as an STL file. If you had clicked the incorrect ones, you would notice that the bounding box here and the mass is pretty large and probably not correct for this particular part. So you can use those to double check that you've selected the right units. After we've set those fields, we come over to the Simulations tab, and this is where all the different optimizations occur. So the most basic simulation we have is standard stock. And what this does is it considers various stock geometries for this particular part and calculates what the sizes would be for that, what the offsets are, and then calculates a CNC machining plan accordingly. Closed die forging is very similar, except that it does starts with a closed die forging instead of raw stock. Once it's done, the simulation spits out manufacturing plans over here. We can see those results. So for this first part, this is if we click the acquire, this is a forged rectangular bar that costs $2,240. And we can see the geometry of that bar right here. Next, if we want to look a little bit more into the milling plan, you can click the milling plan and select individual processes from that plan and see more detailed information down on the bottom. You can also go over to the plan analysis and either click individual pieces of that or click play and watch the entire thing. You can also zoom in to see certain pieces that were more difficult to view because of their short time frame, like drilling. Next, let's take a look at these other simulations. So we had the closed die forging simulation. And if we show the stock material, you can see the parting line and the draft angles. We also have a hybrid simulation, which I went ahead and ran. And what this does is it considers 5-axis directed energy deposition for wire feed. And so there's no support material because it assumes you can rotate the part and print any material. Lastly, we have part divider. That considers whether the part should be split into multiple pieces. In this case, this part probably doesn't. And it can also check if there's some small amount of material that could be removed so that you can fit into a much better stock size. For instance, you're right at the 4-inch limit for plate. Lastly, we'll talk about settings. You can go ahead and click on these individual settings tabs over here or up in the top left corner and edit default settings. Some very specific parameters I want to point out in the settings are the rough milling and finish milling tool diameters, as well as the milling tooltip distance to holder. These milling diameters are used to look in an Excel spreadsheet where you can include all of a bunch of different types of tools, and it'll look for diameters that are specific to those, and you select all those tools and consider them for manufacturing. In the process and stock settings, these are material dependent. So in this case, aluminum 6061 is being shown. If we switch to titanium, the price per mass went up, and so that's the same for stock and process. Over in the simulations tab, you can adjust what is being run in these different simulations. So for instance, standard stock has a bunch of different stock types to consider. Thank you for listening. Enjoy using Part Analyzer. Do let us know if you have any comments, questions, or concerns.